Alright, so given our QBasic prototype that we've just typed out, which exhibits the prototype for like single wave of a level, we went ahead and translated over to HTML5 and JavaScript. So exactly the same thing, except now it's different language, different platform, whatever. And already you notice that performance is smoother just from directly using the whatever, and the lines and circles are pretty and anti-aliased. Okay, so, and as far as the code, it's really, I mean, nothing really complicated. It's almost one-to-one, if not shorter and easier. The only thing is that I'm always having to look up these canvas context methods. But otherwise, yeah, you already see the structure. Really, what the fuck's the difference, right here? So anyways, we have that. Oh yeah, also went ahead and did the critical fix of making sure the spin controls are perfectly intuitive. So I guess now just keep going. So at this point, I went ahead and wrote out the entire game level by level, which is about to play here, and that's basically going to be all the different ball configurations and final output I'll be going with. And the way I did that is, let's see, we take the real time in seconds, and if, and each level is defined by how many seconds have elapsed. So then, when that change of state happens, all I do is, spawn new balls, change the configuration of pegs, holes, and we do that for almost every wave, which can take anywhere, which now it takes 7 seconds per wave, but that can be changed. So you can see some start out with no velocity, with these had some velocity, and then at level 15, which should come up just now, we change the peg configuration into this spinning teacup shape, or like a tilt-a-whirl, which is quite satisfying. So yeah, same shit as before. Red balls hit a white ball, they become green. Green balls hit a gray ball, they get scored. So scoring green ball increases your score or gives you points, while hitting red ball with hole reduces it, and anything that's unreachable, green balls are neutral, red balls take away your score. I mean, who gives a fuck, but that's the scoring system. And yeah, this one is rather satisfying, because unlike the star, it really scatters them around. So let's see how this plays out. Really not much to be said about the code. I mean, we got the physics down, we got the prototype down, and now it's just the after party of, you know, changing colors, fucking adding this, removing that. And in the end here, to show off a bit, I drew this what's called well, this one is called Flower of Life, which is like I don't know, hipster punk rock symbol. And I noticed that if you draw it recursively like a fractal, where the fuck is it? Like here, if you draw it like recursively referring itself, and you decrement the radius each time, you get this shape. And I've never seen it plotted before, the flower that is. So I just want to look at it one time before we stop fucking around. Alright, so you notice how in this configuration it's both self-similar and recursive, which is fuck it, whatever. 1 second. Alright. So I think it's about time we bust out the fucking GL pipeline and start adding hardware GPU acceleration to our game. And in this most conventional fashion, the GPU runs so-called shaders, or these programs that have a certain or have the property of I don't know, independence, and they get pipeline and fucking so you notice how this background color is gray. What we can do is directly in the GLSL code, not even the JavaScript, we can now change it to red, for example, right? And you'd think, oh, that's nothing special, you just you're just drawing a red rectangle. But if you go into the vertex buffer setup, or whatever the fuck, you notice that this is just two triangles. As such, right? The GPU is designed to draw triangles, but it can also rasterize pixels. And what I did is I did the shader toy solution of just drawing two triangles to fill the screen, which, you know, brings the vertex shader down to a couple lines. And then in the fragment shader, I have full control over every pixel with a CLI code that gets pipelined and parallelized in the GPU, which, you know, whatever. So, the thing that's stopping my games from reaching a silk song quality is that in software, I don't have the capacity to do fancy lighting effects. And engines like Godot and Unreal and C# Unity, whatever the fuck, don't have the capabilities to realize my dream game. So it's been a thing I've been putting off, you know, the GL pipeline. And this might be the game where we start making forays into the subject. So yeah, the way you can program this shit is, for example, we'll make everything black. And we say, let's see, red minus geofrag chord dot x, which is, you know, that's just your x divided by, you know, 100. Let's go maybe 800. And we have this gradient that's basically a pixel array that's being computed instantaneously. And then you can go ahead and, you know, do like a minus geo. Yeah, now you have even more blending and gradients, right? And so on, you know, make this 0.5, you know. And you have that. And of course, Now, of course, having a, the typical fragment shader with no data is pretty useless. So you have to pass game, environment, whatever, data to the GPU. And the conventional way of doing that is usually making either a buffer or a texture. But it's, yeah, and textures are really for doing images and then rendering them into triangles for your 3D engines, and then you'd use a fragment shader to do fucking lighting effects, and that's how it's intended to be. Now, of course, you can write whatever you want, and because we're doing this kind of a 2D, 4D suspended whatever, and because our number of game elements is relatively small in the order of hundreds, I went ahead and decided to use uniform arrays, kind of wasting uniform space, to upload game data to the GL pipeline. Now, the shader itself is actually something I explain in detail, rather, the math and behind it in my video, complex vector field, if you're interested. But all I did was I took those heat maps I alluded to in that video and converted them to GLSL. And I actually intend on making future videos on the subject of complex analysis, real analysis, complex integration, all that, where I'll describe my thoughts, my original ideas and all that in detail. But for now, all I did was I took some of those heat maps, translated them to GLSL, and then the part that's profound, I guess, is so here we have 4 different heat maps, but the part that's profound itself is that in our C to C mapping, our complex plane to complex plane mapping, I decided that pegs, that is the white balls, are going to be zeros. Holes are going to be poles or singularities, as well as green balls are also going to be poles and singularities. And finally, we rotate, or we increment the phase of the entire complex plane by multiplying by this e to the I a, and so on. So I made a few of these heat maps and functions, and then this part, you can make fun of, but I interlaced them into the game using U level, or uniform level, as my fucking independent variable, and I'm just trying different combinations of all of what I just said in a conditional GLSL block. And I guess so we have our levels represented here, but also in this switch statement, where during, for example, Act 2, I upload all the uniforms for the new pegs. Yeah, and then so we do the ball physics. We have our whatever, and after all's said and done, yeah, we make a GL uniform array and upload it to the fucking GL pipeline. So you're probably wondering what it actually looks like in the end. And it looks like this. So let me just okay, we'll have 10 seconds per wave. Okay, so okay, let's play the fucking game, yeah. So first for game dev friends, we show the prototype because that's how professionals do it. They first make this kind of bullshit, then they throw in the artwork and assets. In this case, my assets are shaders, which ironically took maybe a couple of hours to type out, unlike the fucking 30 hours that was spent on pixel art in previous jams. And then we simply rotate through, and you see so this is so this takes every point, maps it into a kind of, yeah, I'll do more content on this because I have novel ideas on a mathematical subject that I'd like to express, but it takes a complex mapping and colors it with basically a fake HSL, which I call, HRGBY for hue to red, green, blue, yellow, which you're seeing before you, which creates all these, dynamics and color gradients for the star, for example. And then we have this pinwheel as per the theme. And I'm just waiting for the pegs to switch. Okay, so here's the polar contours. And you see, from, because this game is guided by fuck. Yeah. Okay, here's the checkerboard pattern, which is HRGB3. So this is like that propeller cap thing. You can see that right now the green balls do not create singularities in the complex plane, but they will in the next wave. Now they do, right? Now it looks like this. Because the green balls are now creating singularities, it's created this very dynamical, very busy looking shape. And the thing I just wanted to look at is the HRGB4, which is so this one, HRGB2, is just color gradient. HRGB1, which you've probably seen earlier, next. Okay, this is HRGB1. You see it introduces gradients using, you know, contouring is what, not gradients, contouring. And then HRGB3, which I'm gonna wait for, shows you the polar contours. So what's gonna happen is the white holes are zeros and the black holes are singularities. So field lines will start at white and finish at black, because black is like a black hole. You know, because this game is inspired by quantum postulates. So I just want to see it. Okay, here. So you see how the white balls are. They source a field and the black holes sink a field. And you see basically a bunch of dipoles and tripoles everywhere and whatnot. And they update live at 60 FPS because every pixel is a pipeline on the GPU. And then finally, after all of that, you get to look at this novel fractal, which, you know, I'm sure isn't that difficult to discover, but I haven't seen anyone do it, so this is what it is. It starts out as 6, creates a scale invariant infinitely complex shape, which converts to the, you know, whatever, sacred geometry, whatever the fuck, yeah. So of course, you know, fatigue is setting in. What is there to say, really? Yeah, you see the green balls become a kind of antiparticle that, and then it just changes, because, yeah. And this is just the pinwheel here. Anyways, fuck it, let's call it there.